Hi, today we want to look at translating words into math and math into words, or into expressions into words and expressions, pulling them out of word problems. A lot of times math isn't just written as straight old numbers and operations. Sometimes we have to pull it out of word problems. And in real life, that's really what we're doing most of the time. We're doing that. So we have our four operations: addition, subtraction, multiplication, and division. So usually we know the words plus, minus, times, or multiply and divide. But there are other words that we can use as well when we're evaluating expressions and solving word problems. So let's take a look here first at addition and subtraction. So here we go with addition and subtraction. So here's addition. Look at the algebraic expression. And the only thing that makes it algebraic is there's a variable or there's a letter in there. So that n plus 3 is the way I would say that, a number, something that we don't know, some number, plus 3. But there are other ones here. If we look under verbal expressions here, add 3 to a number, that works. A number plus 3, that's one I just said. The sum of a number and 3. 3 more than a number, and a number increased by 3. And there's plenty of other ones that you could probably think of. You could also say 3 plus a number. So our commutative property works here. The order in which we do addition doesn't matter, so we can move things around with addition, but we can't do that with subtraction. So let's look at subtraction. Our second expression here, algebraic expression, is x minus 12 is the way I see it. X being some number minus 12. Now the order when we do subtraction is important. It is not commutative. We can't change this around. We can't flip-flop it around. So you would subtract 12 from a number. 12 is coming off of the number, not 12 minus a number. That's a different problem. But subtract 12 from a number minus 12. The difference is the answer to a subtraction problem. 12 less than a number decreased by 12. Take away 12 from a number less 12. I don't know about less than. I don't know. I think I would just use less 12. And that's one I probably wouldn't use that often. All right, let's look at two more operations here. Two more operations being multiplication and division. So look here, that 2m means 2 times m, or the dot. We use the dot now, and we're trying to get away from using x because x can be a variable. So we don't want to write multiplication of x times a number because using that x is going to be confusing with what is that an operation or is that a variable. So we try to use different symbols here, or a number right next to a variable means you have 2 of that variable. So this could be 2 times a number, 2 multiplied by a number. The product is the answer to a multiplication problem. Let's look at division. Let me go back here. Multiplication, we can move around. 2 times 3 is the same as 3 times 2. That is a commutative property with multiplication, but there isn't with division. So we have to be careful with subtraction and division that we keep the order right. So here's the expression a divided by 6. So a number divided by 6 is the way I would say that. 6 divided into a number. 6 is the thing that you're taking into the number, or the quotient. Quotient is the answer to a division problem. Now, in algebra, we're going to use the fraction bar and write division as a ratio, where the dividend, the number that's dividing up, is on top, and then we divide it by the bottom. Just like when we were turning fractions into decimals, we always take the top number divided by the bottom number. So you can think of that fraction bar as a division bar. So let's take a look at a few of these, and let's try these on your own. So take a minute and try a couple of those. Okay, so the first one here, the sum of 7 and a number. So sum should ring a bell that we're talking about addition here. So 7, just easy enough, 7 plus a number. So I could write n as my number. You could use any variable. X is used a lot and y are used a lot. 10 subtracted from a number. Now subtraction, we have to be careful here that we get it in the right order. So am I subtracting something from 10, or am I taking 10 away from something? In this case, 10 is being subtracted from a number. So the order here is important. So the number, the variable n, representing that number, and then subtract 10. 10 is being taken off of n. So be careful. Even though 10 comes first in that sentence, in the expression, it's going to be n minus 10. 8 divided by y. So dividing. So we could go 8 divided by y, just the way you would read it there. Or we're going to write it as a ratio, 8 over top of y, or 8 divided by y. The last one here is a tricky one. It says the sum of x and y divided by 7. So x and y, the sum, that's easy enough. That's x plus y, that's a plus sign. But it says divided by 7. Well, is it y divided by 7, or is it the sum of x and y divided by 7? And if you read it carefully, the sum is what's being divided. So I can't just put in division in there, because if I just put this, order of operations would just take y divided by 7. So I could put parentheses in there and do it that way. So that would make me, the parentheses would make me do the addition first and find that sum and then divide it by 7. The other way of writing this would be x plus y over top of 7. And I could put parentheses there or not. That x plus y would have to be done before you divide it by 7. And that is translating words into expressions.